72% of all Americans live in cities with population greater than 100,000 people. If 46 Americans are randomly selected, find the following probabilities. So we're picking 46 Americans. So the number of trials is going to be 46. And as we pick each of those people, we're going to look to see if they live in a city that's greater than 100,000 people. So we're going to define that a success is living in a city with more than 100,000 people. So X is going to be the number of successes. And since we're counting the success that someone that we choose is in a city with the population of greater than 100,000, our value of P is going to be 72.72. Okay, so in the first part it says we're going to find exactly 30 of them living in cities with population greater than 100,000 people. So this is the probability that we're trying to find. The probability that X is equivalent exactly to 30. Okay, so when we look at the number line, we could have 0, 1, 2 that live in a city more than 100,000 people, all the way up to 46. In this case, we're looking at just one value. So that means we are going to use the binomial PDF function on our calculator. So in my calculator, I'm going to go to the distribution list, and I'm going to find the binomial distribution, specifically the binomial PDF. And I'm going to put in there the number of trials, which is 46. I'm going to put in our value P, which is 0.72. And then I'm going to put in our number of successes that we're looking for, which is 30. X is 30. When you put that in on your calculator, you should get 0.0742665789. Now, if we round it to 4 decimal places, which is usually what you want to do in these situations, we have 0.0743. If we write it in terms of a percent, it would be 7.43%. Okay, part B says at most 35 of them live in cities with population greater than 100. So when we look at our number line, we want the biggest value to be 35. So it could be 0, 1, 2, 3, 4, all the way up to 35, including 35 because it says at most, so we can include 35. So we want to find the probability that X is less than or equal to 35. Now, because we're looking for more than one of these probabilities, more than just one specific values, we're going to use the binomial CDF function on our calculator. And as we know, the CDF function on our calculator wants us to enter things that are of this form. So we're already set up to do that. So on the calculator, I'm going to put in binomial CDF. Make sure you're using the CDF function because we're doing more than one value of X. I'm going to put in the number of trials. I'm going to put in my value of P. And then I'm going to put in this value here. For the CDF, we want to put the at most value in, which is 35. Now, when I hit enter and I calculate that, it's going to give me a value of 0.779792501. If we round it to 4 places, that's going to be 0.7798. Okay. The next example says at least 35 live in cities with a population greater than 100,000 people. So when I look at the number line, I want 35 to be the smallest value because it says at least 35. So I want all the values 35 and up to 46. So now we're looking for the probability that x is greater than or equal to 35. However, do you remember that when we use that CDF function on our calculator, we want to make sure that it's of the form probability is of x is less than or equal to some number. So we need to rearrange this in a way that we can calculate this. I want to find these values, which means I am going to subtract all of these off from 100% or 1, and that will leave us with 35 to 46. So I'm going to start and look at subtracting everything from 0 to 34 off of 1. So I'm going to take 1 minus the probability of x is less than or equal to 34. So all of these are subtracted off, and what I'm left with is the 35 to 46, which is what we want. So on the calculator, I'm going to put 1 minus binomial CDF, because we're calculating more than one value. I'm going to put in 46.72, and then if I'm trying to find this value to subtract it from 1, that value of x that we're looking for, that should be the at most value, is 34. When we put that in on the calculator, we're going to get 0.33255 33447, and then when we round that to 4 places, we get 0.3326. Okay, last example. We want to find the probability that the number of successes is going to be between 31 and 37, including 31 and 37. So if we look at our number line, we want 31, 32, 33, 34, all the way up to 37. This is what we want to find the probability for. So what we're going to do is we're going to find, using the CDF, I'm going to find everything that's less than or equal to 37, and then I'm going to subtract off everything from 30 down. So this here is what we're going to subtract off, which is the probability that x is less than or equal to 30. So on the calculator, I'm going to take and find the probability of x is less than or equal to 37, and then I'm going to subtract off the probability that x is less than or equal to 30. And what will be left is that light blue area. Now to do that using our binomial functions, I would do binomial CDF. N is 46, P is 72, and then our value of x would be 37. And then I'm going to subtract binomial CDF, same thing, 46.72, but my value of x in this case is going to be now 30. So when I calculate that and I hit enter, I'm going to get 0.7363744302, and then we round that to 4 places, we get 0.7364.